We are team number 1, and this is our final verification, validation, and testing plan. Our system is called Hood Subsystem Assembly, and the members of our team are Gabriel Salazar, Braulio Monterrosa, Oscar Diaz de León, Stephanie Garfield, and Colin Antos. The purpose of the Hood assembly subsystem of a vehicle is to provide the user operator with convenient access to the front compartment area and to provide environmental and theft protection to the front compartment when the hood is closed. The hood assembly helps protect the engine compartment from the environment. Definition phase. Hood subsystem assembly. The primary tasks of validation and verification management are planning, review, and control. Conceptually, the management's responsibility is to ensure the positive, successful interaction between the validation and verification activities and other system development activities to ensure the creation of a defect-free product. What the system provides? The hood assembly contributes to the aerial performance of the overall vehicle, provides access to the engine compartment. What is the need? This system addresses the needs of accessibility and empowerment for the driver to operate the vehicle in a safer way. Organization and management. These are the functions and the names of our team members. Design Release Engineer, Braulio Monterrosa. Validation Engineer, Oscar Diaz de León. Supplier Quality Engineer, Colin Antos. Program Engineering Manager, Gabriel Salazar. And Customer Interface Manager, Stephanie Garfield. Roles and responsibilities. The following positions and responsibilities are going to be used in the system. Program Engineering Manager. Ensure goals of a project are met through other members of the team. Design Release Engineer. Design responsible of assembly system. Validation Engineer. Plans and monitors the validation test plan. Quality Manager. Oversees all activities and tasks needed to maintain a desired level of excellence. Supplier Program Manager. Coordinates analysis, development, validation, plan and report, and provides a timeline for completion. Customer Interface Manager. Responsible for understanding and managing customer requirements and expectations of the system. Test Engineer. Conducts validation tests and provides results. Vehicle Systems Engineer. Oversees the overall body operations and component progress, control budget, and keeps DREs informed of upcoming deadlines. This slide shows the BBT organization for hood subsystem assembly. In this slide, we can see the master schedule for the project, initiating with the concept, requirements, design, implementation, test, production, and operations and maintenance. Here is the requirements verification matrix used for the project. It contains the unique requirement number, traceability, the requirement, processor title, responsibility, level, verification stage, and what is the verification method for every requirement. Also, a defect log was maintained and updated every week in a configuration management system. The following points were tracked in the defect log: date created, created by, defect description, PM process, lifecycle phase, priority, owner, assigned date, estimated time to fix, status, resolution, resolution date, actual time to fix, and root cause.
Design phase by Braulio Monterrosa. The design phase establishes the reason for the system. The design defines the nature of the system that will be developed and enumerates its goals and risks within technical and business constraints. Validation and verification establishes that risks and constraints enumerating technical, business, or policy considerations that may impede development of the system. Evaluation in the design phase should establish that the objectives of the system, define the user needs to be addressed, and the technical and business advantages that are expected. These objectives may be stated in a variety of ways. It may include a statement of need, a business case, feasibility studies, and systems definition. Systems requirements definition. Period of time in the component lifecycle of a product during which the requirements such as functional and non-functional capabilities for a component product are defined and documented. The main product of the requirements phase, the subsystem technical specification, the SSTS, should accurately state the system's mission, that is, what the system is intended to do. The SSTS should be traceable back to the user and system concept as defined in the concept phase documentation. Master schedule. For this portion, we will concentrate only on the design phase of a product. Here, it will initiate 170 weeks prior of SORP, which is the start of regular production. By this time, program team, along with the design team, will finalize the math concept of the product, which in this case is the hood subsystem assembly. It will source the product to suppliers, and then we will do a design freeze, which means the no math will be modified up to this point. Probably somewhere else along the line, once prototype builds start, then the design can be revised based on the issues encountered during these builds. But at this point, there should be a design freeze and no more changes will be needed. The ADB P&R test plan will be completed, which will address component validation testing, also the system integration validation, and a summary of the V&V activities done at this point in time. Requirements verification metrics. The requirements need to be reviewed and verified and select the VV activity plan phase where the activity will take place. Review and update the RVME will occur at the end of each life cycle. For our case, for our system, we took each of the requirements developed under the ADB P&R and we enumerated these requirements under the RVM. Then we specify at which level the components or the test will be validated. As an example, the hood system slam durability test will be done at the subsystem level, which will be the integration of the hood, fenders, hood latch assembly, and hinges. We will run the durability test, and then it will occur at the verification stage of integration. This is after the prototype builds are completed. The validation team will get a couple of vehicles to run the slam durability. The standard procedure is six durability tests on 6 different vehicles, and based on these findings, we will determine if there are any changes needed or for any of the components that make the hood system assembly. Failure Mode Engineer Analysis, FMEA. The FMEA is a bottom-up procedure for the analysis of potential failure modes within a system or a process, and then determining how to eliminate such problems. In this case, we will develop a system DFMEA. So the system DFMEA will be comprised of the hood, fenders, hood latch assembly. And in this case, we will run the DFMEA of what could be the possible failures that could happen within the system. There are 3 elements of the FMEA, which are the evaluation of severity, occurrence, and detection. The steps that we'll need to take to develop the FMEA are as follows. We'll first identify the functions and scenarios, what could possibly go wrong with the system. We then identify the system of problems that may occur, and then we identify the cause, potential frequency. We estimate the effects, level of damage. Then can such events can be detected or prevented via design or other validation procedures. We identify the priority of the functions, and then we do recommendations for modifications. This is in case something happens during production. Then they can pull out the DFMEA and see what are the recommended actions for this type of failure.
Implementation. The implementation phase consists of key activities that were performed for the hood latching system, which include analyzing the supplier documents for the components and the subsystems, performing random acceptance testing and components, and verifying their consistency with the overall system design allows for one to identify issues. Test standard and component level tests. This component technical specification document, also known as CTS, outlines the requirements for a hood latch, which will be used on all global architectures. The functions, performance, and reliability requirements are defined along with corresponding validation tests. The applicable documents include the following types: industrial and supplier documents. The supplier documents are to be supplied during development, engineering, or manufacturing and assembly process changes, or upon request. Requirements contains the following sections: hood latch definition, appearance, and content. The functional content of the hood latch system shall provide the following functions: to maintain latching of the hood, provide access to the front compartment, prevent unauthorized access to the front compartment, and to provide feedback to the vehicle system as applicable. The functional environment. The hood latch system shall satisfy performance and appearance requirements within the conditions stated to the left. Environmental conditions may include precipitation, hail, snow, dew, or car wash. Contaminants. The materials, coatings, and lubricants of the hood shall not be adversely affected by exposure to these or any other similar materials abnormally expected during use. Vehicle fluids include engine oil, transmission fluid, power steering fluid, brake fluid, washer fluid, ammonia glass cleaner, other fuels, additives, or etc. Atmospheric contaminants could include salt, acid rain, dirt, dust, sand, mud, gravel, oil, or leaves. Interfaces consist of the latch system to operator and to service operations. Product characteristics consist of initial pop-up, primary latch release effort, or freeze, and binds. Validation procedure and component acceptance. This document outlines the planned tasks and expectations for validation of the hood latch assembly. Scope of validation. This validation plan for the hood latching system is limited to the unique components and control systems that define the equipment. This validation effort will be conducted as a prospective validation. This section also includes the in and out of scope validations and the related validation. In this situation, the related validation will occur in support of the hood latching system, which includes all procedures necessary for the system to be placed into operation. Component level validation. The table below is a representation of the requirements along with the procedure titles during the component level validation process. The objective of this validation plan is to outline the requirements that will demonstrate and document that all components, control systems, and functionality associated with the hood latching system are appropriate for a CGMP regulated process. The qualifications outlined are to be based on the Society of Automotive Engineers, policies and procedures, and applicable regulations, guidelines, and accepted industry practices for validation. Periodic review. This plan should be reviewed periodically to ensure compliance and or to determine if a change is required. Subsystem levels. The table below is a representation of a subsystem level validation with the following requirements and its procedure titles. The following two slides provide the table's continuation. Validation strategies. These include project inputs and outputs with acceptance criteria for stages. The project inputs for each stage of the project associated with the hood latching system can be seen in the subsystem and level validation tables. The output of all components and subsystem integrations shall meet the environmental, operating, and performance requirements specified. Loss of function and safety concerns are not acceptable. Acceptance criteria for stages. Defined below are the acceptance criteria for each stage of the project associated with the hood latching system. 1. Component, a part required to build the system. 2. Subsystem, a set of component assembled for use in the system. And 3. System, an integrated set of subsystems meeting the customer's requirements. Validation deliverables. The balance of this plan outlines specific validation activities and products that will be created and assembled throughout the system's development lifecycle and collectively will comprise the validation package. The plan can serve as an overview or a roadmap to the individual validation products as specified by the VBT. Additional detail, including implementation information, can be found in the individual products themselves. Traceability and linkages. This document links the URS, FRS, design specifications, and the testing specifications per the V model to the right. User requirement specifications. This document describes what the equipment is intended to do and all essential requirements such as production rates, operating ranges, etc. It is usually developed by the owner. This document links to the PQ document, which tests for each of the requirements. Functional requirement specifications. This document describes the detailed functionality of the equipment. It is usually developed by the supplier. This document is linked to the OQ document, which tests for each function. Configuration management and change control documentation. Change control is a formal process by which qualified representatives of appropriate disciplines review proposed or actual changes that might affect a validated and/or approved status. The intent is to determine the need for action that would ensure and document that the system maintains this status. This process documents the pre-implementation changes and post-implementation changes. Design specifications may include the traceability matrix. Traceability matrix is the traceability of critical parameters and data through the design process to the final testing stage will be maintained using a matrix. This matrix shall detail all critical equipment and software parameters and link them to their individual test cases and the document in which they appear. The requirements traceability matrix shall be maintained under change control for the life of the equipment. Testing and verification requirements documentation. Testing will be performed in a manner to assure in a complete, verifiable manner the requirements, design, and characteristics of the system and its components. Testing will include the following: testing documents, installation qualification documents, operation qualification documentation, performance qualification documents, deviation management. Operational support. The operational support document will be composed of documentation and written instructions for routine, day-to-day activities associated with using and supporting this equipment, including operating ranges, cleaning, and/or sanitizing. Written instructions will include both end-user instructions and technical instructions for system support. Systems acceptance final report. A formal system acceptance document consisting of review and acceptance of the completed and tested system and validation documentation will be performed to ensure that the expectations laid out in this plan have been fulfilled. This activity will also include a review of any internal audit reports and responses. Acceptance criteria. The different validation products from the validation package for the equipment. Once all validations are completed and approved, the equipment lifecycle moves to the operation and maintenance phase. A systems acceptance checklist will be created to document that all validation activities have been completed. Completion of this plan will ensure the proper installation and functional operation of the hood latching system. Approval of each deliverable defined in this plan will signify that the hood latching system is ready to be used to support production activities, provided all related validation has been successfully completed.
Hello, my name is Gabriel Salazar. Today I am going to walk you through the integration phase of the hood latch system. I will begin with a few definitions and proceed to the bit testing and cost analysis priority testing. During the integration phase, we 1. Combine the system components or subsystems into a complete system. 2. Verify that the system components or subsystems have been built in accordance with the architecture. And 3. During integration, testing is nearly continuous. Built-in test, BIT. The objective of BIT is to automatically or manually monitor detection and isolation of the internal system failures and the propagation of such information to a system component, having the responsibility of operator notification or for the predefined automated air handling or recovery. bit test for the hood latching system. There are two types of test: online, which is an automatic electric test, and offline, a manual test. There is one online test, the built-in hood sensor used to detect if the hood is open. The sensor is active when the vehicle is on. If the hood is open, the sensor will send a visual alert to the user's dashboard, followed by a secondary audible warning alerting the user the hood is open. 2. There are two offline tests. The functional test of the safety latch, if the hood is open, partially secures the hood, preventing catastrophic failures. If the hood is not fully closed, the vehicle will be fully operational even when the hood is slightly open. And the structural test, which is a visual inspection of the fender and hood not aligning. For the hood latching system, there are three levels of test. Operational includes both online and offline test types. Production, at the component level, dimensional checks ensure that all parts meet the intended design requirements prior to assembly. This step verifies that the latch will perform as designed. Squeaks and rattle test, verifying there are no noises at closing or operation. Hood system slam durability, and the hood fit and flushness. 3. The depot, post-production, documented during field service calls. Risk and cost analysis. Risk and cost analysis was performed. Priority was given to those most likely to fail. The top 5 will be represented in the following slide. 4 categories of measure: overall priority, implementation cost, cost of failure in the field, and the likelihood of failure happening. The requirement priority list. The hood latching system will retain the hood in a closed position. This is number 1 on the list due to the results if the hood isn't closed during operation. Number 2, the system shall provide feedback to the vehicle system as applicable. If the alert or safety doesn't work, the user may think the hood is closed and the hood may open during operation. The system will comprise of the following. Number 3, pop-up mechanism shall be able to lift 20 newtons to 110 newtons to a height of 20 millimeters. Number 4, the cable attachment features a primary latch. And number 5, features to prevent noise, squeaks, and rattles during normal operation, as well as opening and closing the hood.
Hello, my name is Colin Antos. I am a member of the Group 1 team. Today, I am going to walk you through the qualification and acceptance testing of the hood latch system. I will begin with an overview of the qualification and acceptance process that will be utilized. I will start with the entry criteria, which defines what conditions must be met prior to the start of the qualification and acceptance test. Then, I will discuss the testing strategy, which will outline the conditions of the physical testing that will take place. In our case, that means the environments and the locations that the hardware will see. Next, we move to the testing sequence, where I will provide the list of tests that will be performed in the qualification and acceptance test. Then, on the details of each test slide, I will provide the details about each of the tests that I listed in the testing sequence slide. I will then discuss the exit criteria, which will detail what conditions must be met to successfully complete the qualification and acceptance test. Next, I will discuss the test schedule and the timeline that will be used to ensure that the qualification and testing aligns with the delivery schedule of the hood latch system. Finally, I will discuss the requirements traceability that will ensure all documentation is revision controlled and traceability is maintained. Now we will move on to the entry criteria. There are 4 main conditions that must be met in order to begin qualification and acceptance testing. First, the hardware must be representative of all other production units. Secondly, all drawings must be released and revision controlled. Thirdly, all assembly instructions, commonly called routings, must be released and revision controlled. Fourthly, the UUT, or unit under test, must be from the first production lot. I will provide greater detail about which tests are performed in which locations and under what conditions later on in this presentation, but for now I would like to introduce you to the overall testing strategy. At a high level, all testing, with the exception of release testing, will take place at ambient or room temperature. These tests will be performed in a combination of controlled, semi-controlled, and real-world conditions. This is necessary in order to properly evaluate the hood latch system in all conditions and satisfy the requirements in the Released Validation Criteria for Acceptance, or VCA, document. The testing sequence consists of 7 separate and distinct events. Each of these events is directly linked to paragraphs within the VCA document. Each of the events is designed to methodically validate the requirements from those specific VCA paragraphs. The next slide will contain the same list, and I will provide you with the details of each test at that time. I will now go into the details related to each of the testing sequence, starting with Initial Visual Inspection, which validates sections 311, 312A through D, and 3141B. 311 requires that the interface between the hood and the body be secure, and upon closing the hood remains flush. 312A through D, it must maintain the latching of the hood, provide access to the engine, deter unauthorized access, provide visual feedback to the vehicle system as needed. 3141B requires that the latch appear uniform and have the appearance of a quality product. This test is located on the production shop floor and at ambient temperature. Next is Test 1, Acoustic Analysis. In this test, the noise shall be monitored during 500 miles of simulated road test and shall not exceed 75 decibels. This will be located in an exposed outdoor course at the temperature of the day. This test shall validate sections 312E, 3141C. 312E requires the prevention of noise, squeaks, or rattles during the operation of the vehicle. 3141C states that the customer expects a quality sounding vehicle during the operation and during latching and unlatching. Next is Test 2, Release Effort. The primary release effort of 300 newtons sealed load shall not exceed 125 newtons when measured within 2 minutes after performing the following steps. 1. Latch the primary latch. 2. Soak the latch assembly at negative 40 degrees plus or minus 2 degrees Celsius for a minimum of 2 hours. 3. Submerge the latch assembly in 5 degrees C water for 10 plus or minus 1 seconds. This test shall be performed at the internal factory garage at the environment that was just described. This shall validate the following sections: 311, 3121A through B, 3131, 3132, 3135, 3141A. These sections provide the details that require for the hood latch to stay latched during operation and be able to be opened with ease when required. Next is Test 3, the lift test. Using a torque meter in accordance with the test described in 321 and 323, the hood latch shall provide 20 Newton meters minimum of lift after primary release when tested using simulated hood weights equivalent to the pop-up forces required per 312. The latch shall have a minimum static latch effort as shown on the table in 323. This test shall be located on the production shop floor and be performed at ambient temperature. This test validates sections 312C, which defines the pop-up requirements. Next is test 4, replacement. A full replacement of the system shall be performed using only tools available at all authorized dealers. This test shall be located at an authorized dealer's garage and be performed at ambient temperature. This validates section 3142, which requires the ability to remove and replace the system at all authorized dealers. Next is test 5, opening torque. Using a torque meter, the hood shall be opened and verified to require less than 10 Newton meters during full range of motion. This test shall be located on the production shop floor and be performed at ambient temperature. This test validates section 324, which requires the hood to be opened with ease. Lastly is final visual inspection, which ensures that the hood latch system validates the same conditions as initial visual inspection, with the addition of validating that the tests performed above were complete and did not result in failing conditions. Further, sections 3133 and 3134 are validated after tests 1 through 5 are complete and ensure that the hood latch system was not degraded by the contaminants and environments it was exposed to during the testing. This test shall be located on the production shop floor and be performed at ambient temperature. Qualification testing can be considered to be complete when all tests are complete with pass, or when all tests with fail are documented on an internal failure report, and have corrective action, and a Delta qualification test has been completed and the result is pass. All testing is in accordance with the integrated master schedule. This ensures that all stakeholders are present and have notification well in advance. Any deviations from the IMS must receive prior authorization by a program directive and will be documented with a revised IMS. The requirements traceability is maintained by strict adherence to revision control requirements. This means that all routings are revision controlled, production orders have unique identification numbers, rejections are documented, drawings are released and are at the current revision, any drawing red lines are properly controlled, test instructions and results are documented internally and are traceable back to the production order. This concludes the section on qualification and acceptance testing.